So let's start our discussion on value stream mapping. So in this particular module, we will gain a little introduction to what value stream mapping is and how does it compare to some of the other mapping techniques, other process mapping techniques. So when we talk about value stream mapping, the first thing that we need to understand is that value stream maps are basically developed for a very high level visualization of a process, like a bird's eye view of an entire process. We are not trying to improve individual processes as a result of value stream mapping. What can happen, and we will get to that shortly, is once we find out where the problems are in the overall flow of the materials, we may identify specific processes or specific areas which may need further investigation for improvements in those processes. But value stream mapping does not have as its aim the improvement of an individual process. The value stream mapping maps are done to look at the entire process as a whole, and the intent is to understand the overall flow in the system, and the term that is sometimes used to denote this is flow Kaizen. Kaizen is a term which some of you may be familiar, but it basically means continual improvement. But what we are talking about over here when we talk about flow Kaizen is our intent is to try and improve the basic flow in the system as a whole, and we do this by highlighting a very high level areas of waste. Okay, some of the other charting techniques, and we mentioned these earlier when we were talking about process mapping, things like flow charts, and there are other process charts which we have not discussed, but there are a number of other techniques that really are used to focus on individual processes, and the purpose of those charting techniques, those mapping techniques, is to identify areas of waste within a process, and this is generally referred to as activity or point Kaizen. That means you are trying to understand how a particular activity is taking place and how you can highlight points or areas of waste so that you can improve on that particular activity as an individual activity. That improvement in the individual activity, as we have mentioned earlier, may or may not result in an improvement in the overall flow of the material. Now, we have discussed this, but I think it is important to keep on, maybe reinforcing the idea that waste is basically incurred in a process when no value is being added to the product. And value is what the customer is paying for. And generally speaking, it is understood as a particular operation which transforms the product either physically or chemically. A third type of a transformation that takes place, which is also value addition, is when you're doing necessary transportation of that particular product, because the customer is not going to come to the plant to pick up that particular product, and therefore the product has to be made available to the customer at a place which he or she finds convenient, at a time and at a price that he or she is willing to pay. So, what are the basic benefits of value stream mapping? We mentioned point Kaizen, activity Kaizen, or process Kaizen, which is what the focus is when you are looking at a detailed process mapping technique such as flow charting. But unlike point Kaizen or process Kaizen, in value stream mapping, the focus is not on improving the individual process, but it is to improve the entire stream of processes, and what are the various steps taken together collectively that are required to fulfill a customer requirement or a customer order. However, As a result of analyzing the entire flow of the process, you may be able to identify where that flow is being held up, where is the discontinuity in the flow, and you may be able to identify individual processes that then can be further analyzed with the help of more detailed analytical techniques such as flow charts and process charts, so that those particular processes can be targeted for improvement. Value stream mapping allows you to visualize, because it's a very visual technique. It allows you to visualize wastes and the sources of waste in the entire stream, because unless you are clear in terms of where the waste exists in the system and you try to improve an individual process without understanding its impact on the overall system, you may improve that process, but the overall system output or throughput may not improve, and therefore you may not necessarily get any benefit in terms of increased revenue or shorter throughput time or better customer satisfaction. So value stream mapping tends to provide information that can be used to make decisions, so that you focus your improvement areas based on specific data. A lot of times we have people saying, I know where the problem is, so let's just go ahead and do this. But as opposed to these kind of gut feel or gut reactions of people, which are not necessarily 100% correct, here you have a technique which is data based, and the moment you have data on the table, it's very difficult to argue or dispute data, and therefore a value stream map is therefore a very powerful technique that helps us analyze a system, so that we can identify the areas for improvement. Another benefit of value stream mapping is that it is not something which you do once. It is something that can be done over and over again, and it lends itself fairly easily to continual improvement. And from the standpoint of lean, one of the things that we want to make sure is that we do not stop at a particular point in time, that we do keep on improving our systems on a continual basis, and therefore the value stream map is a useful tool in lean because it allows us to pursue continual improvement. The other thing that value stream mapping does, which a lot of other mapping techniques do not necessarily do very effectively, is it allows us to map both the material flow and the information flow in one place. And when you see the effect of information flow or any discontinuities in the information flow and the impact that it has on the material flow and the discontinuities in the material flow, that itself gives us a lot of information which helps us take the right decision. In most of the other process mapping techniques, such as flow charting and other process charts, you tend to either map the material or you tend to map the information. But this is one technique which tends to combine both the material and the information flow together. Value stream mapping in general is not done for individual products. Usually it tends to be done for product families. Now, what constitutes a product family we will be talking about a little bit later, but in a very simple manner, it is a group of products. Remember when we talked about group layouts, we talked about families of parts that are produced on a group of machines, and generally speaking, if we have a family of parts that require similar processing on certain pieces of equipment, we would treat those products as a product family. Okay, so generally speaking, you tend to draw or chart a value stream map for product families rather than for individual products. You also do not want to include individual processing steps only where there is a disconnect. What we mean by this is the following. So let's say that we have a process here and a process here and a process here. And if the material that is being transported from these various stages is some kind of a conveyor, so that there is no accumulation of material in between the various processes. If that is the case, then it does not make sense for us to actually map these as three different processes. We would tend to use one depiction of this as a single process, because there is no inventory accumulating in between. However, if we had these processes a little disconnected, so that now you have inventory, and in value stream mapping, inventory is depicted as an upright triangle as opposed to the industrial engineering symbol, which is an inverted triangle. So if your process looks something like this, where after the product is finished on machine 1, it goes and sits in some WIP or work in process area until it is required at process 2. Similarly, between process 2 and 3, there is some storage area where material sits in inventory for some time before arriving at process 3. If this is the case, then we will treat each one of these three as a separate process. So there will be three separate processes here, whereas in this case we will be having one single process which will be used to denote all three steps. Generally speaking, what is recommended, and this is something which sometimes people don't understand, it should be done by a value stream manager. And the first question somebody asks, what is a value stream manager, or who is a value stream manager? Because such a position generally does not exist in organizations. And what you tend to find is, because what we are really talking about is end-to-end value stream maps. That means drawing a map of what happens to a part from the time it arrives in your incoming store till the time that the finished product leaves your finished good warehouse on the way to the customer. Okay. Now, all of the time that a part spends in your system from the time that the raw material arrives in your incoming store till the time the finished product leaves, it goes through a number of areas, and each one of these is a separate area which is managed by a separate supervisor or a manager. You do not have one person who tends to have control over what happens to the parts as they move through all these various stages, going from the first step to the last step and then out to the customer. So what is recommended is that you do have someone who has a say over what needs to happen to the part through the entire journey while it is moving through your plant. And they call that person, let's say, a value stream manager, because his or her area of, I wouldn't like to use the word control, but area of influence would be the flow of the material through the entire plant. The value stream map should also consider both material and information flows, and we talked about that briefly earlier. The idea being that you cannot consider material flow exclusive of the information flow, because the information flow and the material flow has to take place together. If your material flow is separate from the information flow, that is where you have confusion and chaos and inventories and discontinuities in your material system. The value stream map can be extended to processes outside your facility, meaning suppliers. So if you choose to, you can begin your value stream map at your supplier's end and map it to your plant, through your plant, and to what happens to it after it leaves your plant. So that is something that you can choose to do if you would like. Okay, so it can be extended 2 steps outside your plant, and it can and probably should be used to map non-manufacturing activities, because value stream mapping can be just as easily applied to office activities and office processes. You know, what happens to a purchase order from the time that you determine that you need a certain product or a certain service or something that needs to be indented, till the time that an actual purchase order is released. What are all the various steps? These can also be mapped in terms of a value stream map, and the waiting time for that particular order, okay, is equivalent to inventory, physical inventory that you would see on the shop floor. So what are the steps in a value stream mapping exercise? Number one, you need to select a product family for mapping. So you need to have a product family that shares a certain number of equipment which you will use for the purposes of depicting in your value stream map. The second step in your value stream map is to draw what the current state of that value stream map is. That means you would go walk through your plant to see exactly what is happening on the shop floor to this particular product family and map that particular flow of material and information. Once you have created a current state map for this product family, you then would ask yourself the question, what is wrong with this particular value stream map, or as the phrase goes, what's wrong with this picture? Okay, so essentially you would analyze and try to identify areas for potential improvement, and using some of the principles of lean, as we will be talking about in the next class, you would then generate a future state map which is saying what should the value stream map look like. Okay, what should ideally a value stream map look like? After you have developed a future state map, then you would create an implementation roadmap and a work plan, and once that has been implemented, you then use that as a current state map and come up with a new future state map, and this whole process keeps on continuing in the manner of continual improvement. Now, when you are mapping the current state, how do you, what is it that you need to do? A few pointers. Number one, you cannot draw a current state map sitting in an office. You cannot map a particular process without actually going to the shop floor. Remember one of the things that we talked about with regard to the PDSA cycle. One of the things that Toyota and the Japanese talk about, and this is something which people are beginning to recognize more and more. The term that is used very commonly is Gemba. Gemba is the place where the action is taking place. Now, if you are going to try and analyze and understand a certain process, you have to go to the process. So it has to be done, the value stream mapping has to be done by walking through the process yourself. Okay. Don't try to rely on computer printouts and what somebody has told you in terms of reports. The second thing is, it is best done with a paper and pencil. Okay, the best value stream maps are drawn very simply with the help of a paper and pencil rather than with some fancy computer software. And this is something which people find it a little bit difficult sometimes to accept, because there's a whole lot of sophistication that's available with computers. But imagine yourself walking through the process. How would you collect the information? How would you draw a particular process when you're walking through it? The best way is with the help of a paper and pencil. Now the question is, once you have captured that information, why would you waste time trying to transfer that to a computer? Because you can be making all kinds of changes to that, because further information may be available, more information may be available. You may question certain parts of this. So changes are made to that particular thing, which will again be made by walking through the process. What is easier to do? Doing it with paper and pencil, or doing it with the help of a computer? I think the answer is quite obvious. Observations should be taken by the analyst, the person who is actually drawing the map, and the person should not rely on documented information alone. You can use some documented information to see whether or not that documented information is up to date, but do not rely on it. Usually it is best to begin at the customer requirement, which means at the dispatch end. at your dispatch gate and work backwards, work upstream to your receiving area. So you follow the process in reverse order. One of the things that is recommended is if you try to map each and everything that happens to each and every part, you will end up with a map that is so complicated and that is of very little value from the standpoint of analysis. So although when multiple flows do occur, you can include them in your value stream map, but the idea is that it is not important to map each and every flow. You only need to map the principal flows, because the purpose behind value stream mapping is not a detailed analysis, but analyzing the overall flow as to what is happening to the material and information as it flows through your system. One of the things that you do when you are mapping the current state is you have something that we call a process box, and a process box is drawn for each of the processes. You can call it a process box, you can call it a data box, but it includes information such as, and it need not be all of this information in each and every process box, but depending on what you find is going to be important for you, you can record things like cycle time, and we'll define what each one of these terms means in a minute. The number of operators, what are the setup or the changeover time, what is the demand rate or the takt time, and again we will talk about this in a minute. What is the lead time? What is the value added time? That means the actual time to complete the process. What is the uptime, which is a function of breakdown frequency for that particular piece of equipment. The total time available. Are you working one shift, two shifts, how many hours per shift? And generally, what are the percentage defectives that are being produced on this particular machine? In addition to the process box, you would collect information in regard to the inventory, and the inventory would be in terms of the number of pieces that you observe between the processes. Now this is again something that people have quite a bit of difficulty with, because they say if you walk in the morning or in the afternoon on a Monday versus a Wednesday, at the beginning of the month versus the end of the month, things are going to be very different. Okay, and the answer is it doesn't really matter when this information is collected. It is not necessary to go about calculating averages and doing any kind of sophisticated math, because the purpose behind the value stream map is not to have very detailed and precise numerical information. We are looking of orders of magnitude of data with regard to inventory, because we are trying to highlight areas where inventory is accumulating. It does not matter whether it is 7,000 pieces there or 5,000 pieces. Okay, and so specific numbers themselves are not that important. However, if we feel that there is a very significant difference at different times, you may want to consider taking some kind of an average. And you also have to look at how information flows take place when you're mapping the current state. A few definitions. When we talk about cycle time stands for how often a part is completed by a process. That means it is the amount of time that it would take an operator to go through all of the work elements before he or she repeats them. Okay, and that would be the frequency with which a completed part would leave the particular process. Value added time is the sum of all the work elements that are required to transform the product either physically or chemically into the shape or form that the customer wants or requires. The lead time is the actual total time that it takes to move one piece all the way through the entire value stream from the start till the finish, which is the time from the time that it arrives, sits in your incoming stores, moves through all the manufacturing stages, and then finally leaves from your dispatch gate. And this would include both the value added time as well as the non-value added time. Finally, when we talk about takt time is a very important component of value stream mapping. And when we talk about takt time, the takt time stands for the demand rate at which the customer is buying the product. And so if we have, let's say, the demand in one shift is 500 pieces, okay, and if we are working for 480 minutes in a shift, okay, so then the rate at which the customer is demanding the part is slightly more than 1 piece per minute, okay, or it'll be 60 it'll be 1 piece every 60 seconds, okay, slightly more than 1 piece every 60 seconds. So the takt time is the rate at which the customer is demanding the product. And the idea behind using something like takt time is that ideally we should balance our production to match the takt time, because if we are producing at a rate faster than the takt time, that means we are building inventory. If we are building at a rate that is slower than the takt time, then we are not meeting the customer demand. Let's take a look at some of the value stream mapping symbols, although I don't want to spend too much of time on these, but very quickly, and usually people do tend to use most of these symbols, but I'm not so sure if the correctness of using the symbol is as important as understanding what goes into the map. But in any case, a customer or a supplier is depicted in this way, and as I was mentioning to you, the process block is shown in the form of some sort of a rectangle, and it indicates the process. This is the data of the process which I talked about, which includes cycle time, changeover time, uptime, and so on and so forth, and this is generally placed before the process block. A machine cell, a work cell is generally depicted in this manner. Inventory is an upright triangle. Dispatches, outbound dispatches, are in the form of arrows such as this. Now a broken arrow is used to denote push. When you are producing products using the push method of scheduling, you will tend to show this, and again we will see this when we take a look at an example. Supermarket, again I will define when we get into the example, but a supermarket, and some of you may be familiar with the term because you may be using these in your plants, is depicted using this kind of a symbol. When you use pull is depicted in this manner, indicating that a customer process is pulling from a supplier process. A first in first out lane I will define if and when we need to, but it's basically where you don't have any pull, but wherever the part gets into a certain channel or a lane, it moves by first in first out because the two processes are directly connected. When you have an external shipment, you tend to show that with the help of some sort of a truck. Then there are different types of Kanbans, which we will again discuss when we get around to them. There's a production Kanban, a withdrawal Kanban, and a signal Kanban. And a Kanban post, which is where these Kanbans sit, is depicted in this manner. When we use some kind of a computerized scheduling or a planning system such as MRP or ERP, we tend to denote that using this symbol. And this is used to indicate that you need to go and observe what is happening and then analyze the particular process. A Kaizen burst is a focused improvement on a particular area, and this particular symbol is used to denote a Kaizen burst, and we generally tend to indicate an operator in this manner, or sometimes we also tend to do it in this manner. Okay.